So today we're going to review multiplying and dividing in scientific notation.
Will we be adding in scientific notation?
Tomorrow we are going to do adding and subtracting. The process is a little bit trickier than actually for multiplication and division.
So it's harder?
You just have to watch out for something different. Okay? In this, with multiplying and dividing, you don't, the exponents have nothing to deal with the problem. You don't have to worry about them. They could be anything. And your decimal values could be anything, and you could do the math with them. When it comes to adding and subtracting, if the exponent doesn't match, then you can't actually do the math. So you have to force a match to happen. So we'll talk about that tomorrow. Okay? Yeah. And once you get the pattern, it's pretty simple of what you do. And so there we are. So when we were multiplying and dividing in scientific notation, it breaks into three parts. We do math with the decimal values. We multiply if it's a multiplication problem. We divide if it's a division problem. We keep the times 10. And then depending on if it's multiplication, we add the exponents. Or if it's division, we subtract the exponents. So we'll write that down. So with multiplying and then divide. So we'll talk about divide. So first, we're going to multiply the decimal values. And we kind of are thinking about them as being coefficients in a way. So remember what I told you is when we are going to take test questions, you most likely are going to have terminating decimals when you do the division, or it's going to be simple division, so it's not going to be as complicated. So it's nicer when you have to do something hard, and then you get to follow up with something easier. I think sometimes if you start with something easy, then you get pretty sucked into doing something easy, and you don't want to try something hard. So for those of you who didn't try last night, you're going to have to try. Now, when it comes to dividing, the only thing that changes in that first set is the math we do. We're going to divide the decimal values. So again, we still are thinking of those as coefficients. The next part is the same for both of them. You're going to keep the times 10. Okay, we're going to keep the times 10. And then the third has a slight variation depending upon what you're doing. Jacob, we're taking notes. Okay. On this one, you're going to, with multiplying, you're going to add the exponents, because that's what we do with the product rule tells us to do. And then the quotient rule tells us you're going to subtract the exponents. Bless you. So the processes are pretty similar. The only thing that you have to watch out for is the actual operations that you're doing. Most of you seem to be better at multiplication than you do with division. And so that's just something that you guys are going to have to go back and practice. So why are we taking notes if we already have all this? Aaron, take your pencil off your head. Thank you. Well, because the problem I'm going to give you is going to require you to do both of those in the same problem. Yeah. So let's look at, I'm going to wait. Okay, so let's put them together into one problem. 2.5 times 10 to the 7th, that multiplied by 7 times 10 to the 4th power, divided by 2 times 10 to the negative 6th. Not as bad as you think. Big old whiny baby. Okay. So what do you think would be the first thing that you would do? First thing that you would do. Jacob. Yeah, we're going to take care of the multiplication first. So do multiplication first. Okay. Giovanni.
We put 2 times 10 negative 6 to the top.
No. And again, because our process doesn't bring it up, what it does is it tells us to subtract exponents. So we're not going to be like we would when we just had 2x to the negative 6. We're not going to bring x to the 6 to the top. That's not what we'll do, okay? So we're going to start, and we're going to do 2.5 times 7, and then we have keep the times 10, and then we're going to add the exponents. Okay, at this point, the denominator is not budging. Okay, so off to the side, I'm going to multiply 25 by 7. That gives me 35. 14 and 3 is 17. I go back and count how many digits came after the decimal point. There was 1, so my answer gets 1. So now I have 17.5 times 10, and 7 plus 4 is 11. And now I bring in the denominator. Now, notice that my numerator is not in scientific notation, but I'm not done doing math, so I'm not going to worry about it yet. I'm only going to worry at the final answer, okay? Next, do division last. Okay. So that means I'm going to take 17.5 and I'm going to divide it by 2. And now with my exponents, I'm going to subtract them. So I get 11, take away negative 6. So off to the side, I do 17.5 divided by 2. Decimal point's going to come on up. 2 goes into 17 8 times, which is 16 with 1 left over. 2 goes into 15 7 times, which is 14 with 1 left over. I'm going to bring down a 0, and 2 goes into 10 exactly 5 times. So I get 8.75, and notice that that number is between 1 and 10, so that's good for scientific notation. But what I need to remember is when I'm doing subtraction problems, I can rename it as adding the opposite. So the sign of the first guy didn't change. So now I just have 11 plus 17, or 6, and 11 plus 6 is 17. And again, the last thing I am going to do is make adjustments if necessary, but we don't need to. So that's why we don't make adjustments in the middle of doing a problem. We only make it at the very, very end of the problem. Now, you guys are groaning and moaning. Was that problem that hard? No, it really wasn't that hard. All right, so let's do one more so that we can practice it again. I'm sorry, what? They're going to be very similar in terms of how difficult. But what I'm going to share with you is a second way of solving the problem. Okay? So you get an option of what you're going to do. Okay, everybody good?
No.
Lovely. Okay, let's try another one. Which one do? Oh, well, it was this one I wanted to do. Okay. So 3.3 times 10 to the 5th, and I want to multiply that by 9 times 10 to the negative 5th, and I want to divide that whole thing by 6 times 10 to the 6th. So here's the second way of doing this problem. What if I pull out all the coefficients at one time and I deal with all the exponents at one time? In other words, I have 3.3, it's not very good, 3, times 9 divided by 6, and I'm going to multiply that by 10, and in the numerator I have 5 plus negative 5. So those are the two that are getting multiplied. But then I'm going to take away 6 because of the subtraction with the division. Okay? And now something that I can try that might make this a little easier is because of the multiplication and division, I can look for simplifying. Is there anything something in the numerator shares with something in the denominator? Taylor?
3?
Yeah, they have a 3 in common. So I can say 3 goes into 6 twice and goes into 9 3 times. So now I've got a little bit of a smaller problem to solve. So here's what I get to do. Off to the side, I get to multiply 3.3 times 3, which is 99, but there was one digit after the decimal point, so I get 9.9. And now I'm going to take that answer and divide it by 2. So 2 goes into 9 4 times, which is 8 with 1 left over. Bring down the 9. 2 goes into 9 9 times, which is 18 with 1 left over. And I can bring down to 0. And 2 goes into 10 5 times. So I get 4.95 times. Now I've got all this other stuff to do. So what's 10 plus negative 5?
0.
So these cancel. There is 0 pair. And with 0, take away 6. So I get a negative 6. So what I did is I did the 2 steps at the same time. Now, if you don't feel comfortable with that, you don't have to try it. You could go back to the other way. But the answer is already in scientific notation. I don't need to make any adjustments, and that's it. Okay? So that's it.